Welcome to another episode of the Hacklab Podcast Safety Leadership Series, where we bring conversations with industry leaders shaping the future of safety and engineering. Today's topic is production is must, but safety first, a challenge faced across every industry where production pressure often tests safety priorities. Joining us today is Mr. Chirag K Baxi, a structural rehabilitation and corrosion control specialist with over 42 years of experience in forensic engineering, damage assessment, and sustainable construction practices. From technical innovation to engineering ethics, his journey offers valuable lessons for every industrial leader. Sir, thank you for joining me today on this show.
Thank you, Mr. Amar. It's my pleasure to be with you to share whatever little I know about safety. As you rightly introduced me, I am basically a construction person and a rehabilitation and a corrosion control person. But yeah, I have come across safety matters, safety issues, many issues during my professional career of 40 plus years. So those experiences will be shared with you on this platform and let people know that what care should be taken and how things should be handled when they come across those type of situation.
Right, sir. So let's get started.
Sure, sir.
Yeah. So when industries face aggressive production targets, why does safety often becomes the first compromise point?
Very true. Yeah, aggressive production targets is very important. Yeah, every industry faces those targets because ultimately they are market-oriented, entities, and they have to survive. And for survival, they need to have aggressive targets, and they keep on changing every month or every situation. I tell you, safety is a mental attitude. Safety is not just an engineering practice. It's not just an engineering ethics. It is beyond engineering. It is a mental attitude. And when you accept when one accepts safety as a mental attitude, probably many of the things get streamlined automatically. Coming back to industry production as a production targets, I would like to share some two or three examples come to my mind. Let me share them. I think some lessons will be gathered at the end of those examples. One is there's a boiler house. I have a background of chemical industry, so my things may have more things on chemical industry. In boiler house, there's a shift of 8 hours and 400 metric tons of steam production is our target normally for every shift. Then now when operator observes at the 6th hour, there is some humming sound. He comes and reports to shift manager, Mr. Manager, I am listening to some humming sound in one of the pumps or one of the piping connected to pump and some elbow, and I do not know. I never heard this humming sound before, but then there is something wrong. Then the manager says, "Come on, it may not be so serious because there is no parameter is going unsafe. I can see on screen there are no parameters going unsafe. So let's continue that. Okay, keep a caution board there and let's keep it in observation. Okay, fine. Like any patient is kept on observation. Keep it in observation and let's complete the 400 tons in our shift and make a logbook note that the maintenance people should come and rectify and see the humming sound in the next shift and let them do it next shift." The shift ends, 400 tons are achieved. The next shift ends up into a disaster. Elbow fails. Steam at a very high pressure comes out of the elbow, and what can happen? It's an unsafe thing, and the thing happen. I'll give you a second example. In an industry manufacturing vehicles, automatic vehicles, travel vehicles. In that industry, in an assembly line, there is an EOT crane. Now, EOT crane is moved by a hand switch. So, hand switch, the operator some suddenly feels hand switch is getting hot here. What is wrong? He tells his manager, the switch is getting hot. The manager says, "Okay, fine. There might be something." No, sir. I feel that EMCB or LCB is getting a little bit hot It's getting a bit disturbed. Okay, yeah, come on, leave it. Take the assembly. I have to complete 30 assemblies in this shift. If you have to complete this, just take it and this thing. So the person by bypassing ELCB and MCB, he completes the EOT crane work, and in the next shift beginning, whenever the person starts EOT crane just goes and collides on the next end, and what can happen? It collapses. The third example I would like to give from my own industry, that is construction industry. 13-story building is under construction, and a slab of 6-story, which is going to consume up to 750 bags of cement material, concrete. And the concrete is being taken up by the trolley, a moving trolley, vertically moving trolley. The person observes it is to be completed in a continuous. It's a continuous process. It cannot be stopped. So after about when I think 150 bags are left out, operators feel when the trolley passes between fourth and fifth floor, I see some shaking. Come on, yeah, shaking. It's a normal thing. You may not be operating properly. Forget it. Complete the thing. When the trolley completes the last load, when it's coming down, the trolley collapses. The whole tower collapses. And few people were trying to, catch the trolley to come down. They fell down. What can happen? Those things, production targets, achieving the production targets, people comfortably ignore safety. I tell you, safety is very, very, very conveniently, ignored. I'll put it the word very conveniently ignored. You don't need to go for equations and algorithms to compromise safety. That is what happens. And in any industry, chemical industry, vehicle industry, construction industry, you can take an example. Yeah, people try to comfortably ignore the safety.
Okay, sir. So, sir, in structural rehabilitation and forensic engineering, what are some common warning signs organizations ignore before a major structural or operational failure occurs?
Structural rehabilitation is a process. It comes after the structure has already damaged. The structure has already undergone distress, or maybe undergone some corrosive effects, or maybe started underperforming, and then rehabilitation or forensic engineering investigation comes into play. Mm-hmm. What we have seen during our journey of more than 2.5 decades of assessing the structures and corrosion survey and all those things. So the initial signs, as you rightly asked, initial signs would be orange spots on concrete surface, which represent rusted corrosion on reinforcement bars. They rust on corrosion reinforcement bars. Cracks along the reinforcement bar lines. That also is one of signs, which is very, very, very visually it can be seen. Number 3 is white efflorations, white spots on the concrete surface. Mm-hmm. Number 4 is honeycomb texture developing on the concrete surface, slowly developing on the concrete surface. Number 5, there may be some growth of vegetation through the concrete mass. Now, concrete mass is supposed to be very, very cohesive and very, very compact mass. But then, if some vegetation can grow through that mass, you can understand what would be happening within the mass. Mm-hmm. So these are the signs which people should not ignore. You may not find it so significant, but then their consequences are significant. Their consequences are disastrous. So these signs should not be ignored, and this should be taken up very seriously.
Okay, sir. Yeah. When you suppose you see these signs, what would the next steps be? What should they do next when they see these signs?
Yeah. If the facility owner is competent enough to evaluate those signs, or to convert those signs into a meaningful evaluation, a meaningful meaning of those signs, then the person would be able to find out what's the magnitude of distress and what's the severity of distress. If the facility owner is not able to do that, he should call an expert. He should call a person who knows the subject thoroughly well, and he can know. Forensic would be the right person, but then everybody may not go for forensic person. But I mean, at least a knowledgeable person who can evaluate those cracks or those textures or those efflorations or those orange signs or those maybe some deflection, maybe some distress. I mean, something happening, because concrete is plastic material. It's not elastic material like steel. So concrete, when it deflects, then it doesn't give any more time before it fades. So some deflection also might be there. So people should be called, experts should be called, and let the expert evaluate the severity. If severity is small, then immediate actions are to be taken. If severity is moderate, then accordingly actions are to be taken. And even actions are designed precisely. I use the word tailor-made. They're precisely designed for those distresses. The root causes which cause those distresses. That's very, very important. Root cause analysis is very important, and that's what we normally do. Sometimes we find there was one leakage. I'll kindly give me opportunity to give an example. I was investigating some water leakage in industry, and that was at some location where there was no source of water. How can it happen? How can it happen? I examined the whole plant, and would you believe, Mr. Ambar, the root cause was welded connection of the members. There was no allowance given for members to expand and contract during heat and cold temperature, hot and cold temperature, and the piping connected to those temperature also went on expanding, contracting like that. But there was no room given to the expand contraction. So piping at one place, hardly for 500 feet away from that leaking point, started getting was cracked, and liquid from that thing found its own way, and the way the point where it found to come out, it came out. So it's a very funny thing that the thing we have to have a very comprehensive analysis of what is happening, and people should be called, expert people should be called to review those things.
Right, sir. So, sir, how do you define the relationship between productivity, quality, and safety? Can one truly exist sustainably without the other?
With your kind permission, may I rearrange your sentence? I would rearrange in a way: safety, quality, and productivity. I'm sorry to rearrange your words, because qualitatively, or maybe functionally, that should be the right sequence. Safety first, as we rightly said in the beginning. Safety first. Safety should always, and they're all interlinked. They're linked. Quality, safety, productivity, even timeline to some extent. Even timeline to some extent is linked with the perfect success of the whole production activity. But safety has to be a first one. Quality, if you are asked for a product of 100% purity, and if you sell 90% purity, a product will be rejected. So it has to be 100%. So purity and quality has to be there. Safety has to be there. Sir, I tell you, if you try to if you have come across one unsafe event or unsafe thing happening somewhere, some pipe was leaking or somewhere some bolt was loose or something, some unsafe thing you observed, it will take only 2 hours to rectify. But if you continue with those loose bolts and loose connections, and maybe the looseness or crevices in the pipeline or whatever looseness and if some disaster happens, it will take days to come back. Outage of production will be for days. For rectifying those initial observation of unsafe event, it will take few hours. So one has to be very, very conscious that safety has a direct link with production. Again, quality. You can't be okay in the fast production, or maybe quick production, or maybe coming back to production in a very less time. Somewhere you compromise with the quality sometimes. And I've seen in my career that you need 4 pipes of 6-inch diameter, right, or 6 mm thickness. Do one thing. Take 6 pipes of 3 mm diameter, 3 mm thickness, and some diameter. I do not know. Are you reducing diameter, or are you reducing the sustainability, reducing thickness or sustainability? So in the process of extending the timeline, sorry, reducing the timeline, or achieving the production fast, you may be sometimes sacrificing the safety at a long run. So
Mm.
safety, quality, and productivity are very much linked, and they have to be addressed holistically.
Mm. Okay,
Yeah.
so sir, I understand like safety has to be first. You understand that, I understand that. I think if we go on the shop floor, everyone will say safety first. But
Have
if everyone will say, then still there are accidents. So the question is, why are there accidents then?
I tell you, I tell you. I'll Can you permit me to give you one example, very solid example, which has really happened, and I used to be very closely associated with that event. There was a ammonium nitrate plant, ammonium nitrate manufacturing plant, and as you know, ammonium nitrate is an explosive product. You use it for bombs and you use it for explosions. 10 ton of ammonium nitrate tanker was to be filled up, and after it was filled up, within 3 minutes it got blasted. So can you imagine 10 ton ammonium nitrate getting blasted? You need 10 milligrams of ammonium nitrate for a cracker, and
Okay.
10 ton. You can imagine what magnitude, 10 raised to how many zeros, or how many, I do not know. So those things, when we investigated, I was associated with those investigations. When we investigated, will you believe, it was sheer, shall I use the word negligence? It was sheer
Mm.
complacency. Shall was near. The tanker SOP, safety SOP for those things, very very sensitive area. So safety SOP did very specifically say that the tanker must be thoroughly cleaned, washed, removed of all the things, organic metals and everything, and it must be checked what was their last filled in this tanker before the tanker came for this filling.
Mm.
Sir, that was unfortunately missed out. The last filled material was organic solution in that tanker, and I do not know to what extent it was cleaned. It was cleaned from inside, and there was some organic metal present inside the tanker, and the tanker got blasted. It took about 4.5 months to come back to normal production. Can you imagine what a negligence pays? What a negligence has to pay? What it has to what disaster? I mean, what disaster? I mean, it's a great thing. So, coming back to your point, when if you make safety a mental attitude, make safety a mindset, then you will not come across this type of things. uh, the people who are connected with industrial operations, they have to come out of, I'm sorry to use the word, they have to come out of these stupid videos of Instagrams and Facebooks. I see them watching them in a control room or in a office area. They have to be on site, they have to be observing the things very closely,
Mhm.
and they have to see that, so those things, any small minor observation, it will take 1 or 2 hours for outage of production. You can convince management, sir, if I do this, 2 hours outage, if I don't do this, it will be 20 hours outage, or maybe 200 hours outage, I do not know. So
Mm.
please try to rectify this unsafe condition, and please try
Mm.
to see that I come back to normal, and please try to ensure that my system is safe and sound to produce not 400 tons of steam, 600 tons of steam in a shift. And
Mhm.
I'm so strong and so strong, but safe, very safe.
Mm. Mhm.
That's what should be
Right.
the attitude.
Right. So, okay. So you have worked extensively on damage assessment and rehabilitation. What are the most common leadership mistakes that delay the corrective action?
Mm, I'll put the budget economics on the top.
Okay. Okay.
Yeah, economics plays its own role, because whether you may like it or not, economics definitely controls all activities. So sometimes you don't get funds, Sometimes you don't get timely funds. Sometimes you don't get the desired things. In limited funds you have to manage, and in that thing, I do not know to what extent the correct actions are implemented or even designed. You may not be able to get the right people or right people executors or right consultants or right materials, or there may be so many things which may be influenced directly or indirectly by the economics. Number one.
Mm.
Number two, I would like to put, with all due respect to all the industry leaders, complacency.
Mhm.
Nothing will happen here. Please continue. Nothing will happen. Complacency. I have seen in my career of 40 years, 30 years, 20 years, nothing has happened. Oh, the humming sound is a very small thing. Slight shaking is a very small thing. You do not know that very small things when can become very big thing. I do not know. I just do not know.
Mm.
So those things, complacency, economics, and
Mhm.
just that attitude, sometimes has a very, very, very sour sound, very, very, very sad sound.
Right, right, right. Okay, so how important is ethics in engineering and safety decision making, especially when business pressure demands faster execution?
Engineering ethics. Engineering ethics will start and end with the formation of SOPs,
Okay.
standard operating practices. When you have a standard operating practices, when you have you have a schedule for lubrication, schedule for inspection, schedule for critical equipment inspection, schedule for timely maintenance, schedule for building inspection, schedule for when you have a real uh, specific instructions for maintenance team or for the operating team to see that healthiness of their equipment or their machinery or their items are there, then there won't be any pressure. There won't be any extra effort which one will have to make for making the things safe and sound for equipment. And one thing I would like to, I'm reminded of one thing. Safety is not limited to only personal safety gadgets. Not only on
Mhm.
helmets, or not only safety shoes, or not only safety goggles, or not only hand gloves or safety belts. No, safety goes with the attitude. Safety goes with the SOPs. Safety goes with the mental attitude also. So when SOPs are perfectly made, then those things. You may have any pressure. You may have any pressure.
Mhm.
Quick production, fast production, maybe little more than capacity, 120% capacity. Yes, you can be. When you are sure that your system is perfect, sound, and safe, you can always produce, no problem. Yeah,
Okay, okay, sir. So,
yeah,
in your opinion,
yeah.
how can organizations build a culture where employees feel empowered to stop unsafe work without the fear of production pressure?
That is what I think I replied this in my previous question. If you have standards laid down on a piece of paper, when your instructions are very clear to the, even management knows that unsafe things will have to be stopped, will have to be rectified on the spot, on the online. You cannot wait for management approval, and you cannot wait for things to happen, then I'll rectify. No. So employee will be very free. Safety is not a luxury. Safety is responsibility. Safety is not a luxury. Should not be taken. Oh, I'll take approval, and you don't have time, sir. You don't have time to rectify your unsafe things. You must understand that, and for that, employee should be given that responsibility, not a luxury. It is not a perk. It's a luxury. It is a responsibility of employee that he shouldn't be punished. Why did you stop for 2 hours? Okay, had I not stopped for 2 hours, it would have stopped for 20 hours. So management must decide a policy wherein any unsafe act or any unsafe incidents must be immediately brought to the notice, immediately parallelly rectified, parallelly brought to normal, at least for the thing to run, and by the first aid rectification, followed by permanent rectification. That should be there.
Mhm.
And you asked me one thing, what management? uh, how the leaders should be acting. People also, as I said, economics and complacency. People sometimes go for short term stop gap arrangement. इतना कर दो ना हो जाएगा यार, छोड़ो यार. And so in that stop gap arrangement, what happens? You just rectify those things, but do not know that like corrosion. If corrosion has taken place in this area and rectify this area, you do not know whether corrosion is propagated within the paint film or within the concrete surface up to one more two more meters. You do not know. So
Hmm.
stopgap arrangement or short-term arrangement should be discontinued. It should be a systematic, complete treatment, so that you avoid safety from grassroots.
Hmm.
Your unsafety from grassroots.
Hmm.
Yeah,
Right. So finally, sir, if you have to give three practical recommendations to industrial leaders to balance the production with safety, what would they be?
fine. Thank you. That's a very nice question. I mean, I like this question. I always say, of course, safety. I've spoken a bit little less as compared to my structural rehabilitation, but I always believe I'll speak three sentences. Number one, safety is a mental attitude. Safety is a mindset. Safety is not. It is beyond engineering practices. Number one. Number two, 10 minor or near miss incidents lead to one major incident. Stop at first or second or third. Don't allow it to go to eighth or ninth. Or be ready for 10th. That is before. And that will be disaster. Stop at first or second. 10 minor accidents and end up with one major accident, and that is my experience says that. Unfortunately, I've experienced that. And number three, safety is a function of survival, and survival is a function of safety.
Hmm.
That is very true. Survival is a function of safety. Safety is a function of
Hmm.
survival.
Hmm.
These three things, if any industry leader or even a worker, when these three things are kept in mind, they are religiously holistically digested and practiced in a professional career, no unsafe thing will happen. Things will be safe. Let's be safe. Let's not try to restrict safety only for the 4th March National Safety Day. No, every day is a National Safety Day. Every day is a National Safety Day. Every minute is National Safety Minute. Why should we restrict? Why 15th August is only national? No, nationality should be there every day. Like safety should be there every day. No,
Hmm.
there is no day for safety. It's always for safety. Life is for
Right.
safety.
Right. Thank you, sir, for this insightful and meaningful conversation. Your experiences clearly remind us that safety is not separate from production. It is the foundation of sustainable productivity, operational reliability, and long term success. Whether it is structural integrity, corrosion control, engineering ethics, or leadership accountability, the message is simple. Ignoring safety may save time temporarily, but the consequences can last for years. Thank you once again for sharing your valuable knowledge and life experiences with us. To everyone listening, do share this episode with your teams and follow the Hacklab Podcast Safety Leadership Series for more such conversations. Yes, sir.
Thank you very much for giving me opportunity, giving me platform to share my views, because I do not know, few people may like it, few people may not like it, but then I've tried to uncover the hard facts and a bit harsh facts also. But then please follow them holistically and religiously. World is yours.
Yes, sir. So, thank you for everyone for joining. Until next time, take care and have a nice day. Bye bye.